about that video is the out of tune B actually has a purpose because it helps you when you're trying to graph your own linear equation. Okay, you guys are going to need one of those straight edges, and you need this paper in front of you. So as you are very familiar at this point, and if not, it is burned into your brain, that so far the format of every equation that you have learned how to do is in the format y equals mx plus b, right? Now, b, recall from when we do word problems, even though it actually stands for some like Greek word that I really should know the answer to for like, I don't, and I say that every year, and I'm like, I really should just Google it so I know. But B, I like to think of it as where you need to begin. So what I like about this video is that lady definitely just burned B into your head, into your brain forever, right? Because that B in your slope-intercept form of an equation is where you're always going to begin when you need to graph your own. So because it's the y-intercept, what number, by the way, is the b in our equation right here? Positive 5, right? So everybody needs to put their first dot right on that y-axis at positive 5. When you're given an equation in slope-intercept form and you're asked to graph it, I'll get you paper, baby, my fault. When you are graphing a line in slope-intercept form, you're going to go straight for that B, that beginning point, and that is always where your first dot should go. Now, the M, go ahead, stands for your rate of change, also known as your slope, right? So that's another key part of the song. It's not that hard, it's rise over run, okay? So what number in that slope is your rise? The 5, right? And I love that somebody brought my attention to the negative 5. I'm going to come back to that negative 5 in just 1 second because you're right. There's actually, no, I'll go ahead and roll with it for right now because you're right. I'll go ahead and address it now, actually. So you're right, negative 5. So when you think of a negative 5 relating to your rise, even though I haven't shown you how to do this yet, what does your gut tell you about what direction you're probably going to move in if it's a negative 5 and it's your rise? Down, exactly. So what you're about to see on the graph is not part of the answer. It's just me giving you a visualization of where I'm getting my coordinate from. So I kind of visualize. So from that beginning point, you're going to go down 1, 2, 3, 4, and 5 down. And then what is the run for my equation? Or for my equation, yeah. 2, right? Now, I am getting ready to do something wrong, okay? And you're going to know that because it's in red, so don't write it down. Okay, but it logically makes sense that you would think, hey, it's a negative slope, so I'm going to go down, and then I'm going to go to the left, too, because, it's a negative slope, right? Oh, but the same way, I love where your head's at. So you know those integer rules, like why do I need to know a negative times a negative? Like I can just use a calculator. Here's the reason why. Because 2 negatives make a positive in integers, but they also make a negative in direction. So if you do it this way, if you go down 5, which is negative, right? And then you go to the left 2, you've gone negative and then negative again, and 2 negatives make a positive. So if you were to graph that line, is that a line that's decreasing like that slope says it should be? No, it's increasing. So if you go down and to the left, you're going to go negative, negative. You're going to get yourself a positive slope instead of the negative slope that you need. So do not go to the left. Instead, we're going to go to the right. So again, this is not part of the answer, the little loop-de-loops I'm doing. It's literally just something to help you visualize where I'm getting my coordinate from. So my next dot, my next coordinate, which is actually the big kid word that I should be using, will go right there. Now, every math teacher in America, well, that's worth a darn, I know there's a lot that aren't, are going to tell you that you need to have 3 coordinates in order to make sure that you've got your linear function graphed correctly and to make sure you've got it lined up right. So once we've got our second coordinate there, you're also going to need to go down 1, 2, 3, 4, 5 again, and 2 to the right again, so that now you've got that third coordinate just like that. Yes, Dia?
Why did you put the third coordinate?
So because it's a linear function, you know how yesterday we found the slope of the line, we just did it in different places? That's all I'm doing right here is I'm showing you all the different places that fall on that line. And the reason that most teachers are going to require you to do 3 is because even with a ruler, sometimes with 2, you might not quite have it lined up right. And even though it seems like I'm being petty about making your line go all the way across the graph right now, when we get to different problems where you're going to have to graph them more than one at a time, if you don't make your line go all the way across the graph and you don't make it straight, you might end up with the wrong answer. So right now, honestly, I am kind of being a little bit petty when I say things like this. Don't give me a line that just goes through the segments like that, okay? That, especially the high school teachers, they don't like that. If you're going to Ballard or Manual, don't you dare do that. They are not going to be happy with you. Okay, so you want to make a line that goes all the way across the graph. Right now, again, just take my word for it. There will be a good reason, actually, for you to make it go all the way across the graph, but you won't see that good reason for a while. And technically, that line extends forever and ever and ever. We just don't have a graph that goes forever and ever and ever for our paper, right? So you also need to add arrows to either side to make sure that it's mathematically correct. When I taught at Ballard, every math classroom literally had this 5-point rubric of things you had to do in order for them to accept your paper when you're graphing a line. It had to be a ruler, you had to have 3 coordinates, you had to have your arrows on either side, you had to label correctly. It was a whole thing. And I know Manual is no different. So I know that's where a couple of y'all, Male, I don't know because I don't have anybody there that I know. But so make sure it's not going to be all the way counted correct in your future if you don't make that nice straight line, put arrows on either side. Okay? So start at your B, your beginning point, and then use the rise and the run to figure out where your next at least 2 coordinates, 3 total will go. So any questions about number 1? All right, so for number 2, we're going to start off the same way. MX plus B. Where's my beginning point for number 2? My first dot. Oh, this is also something I see people do a lot. What's wrong with that? It's on the x-axis, okay? This is a y-intercept. We are going to talk about x-intercepts, but not for a hot minute, okay? That is a y-intercept. Slope-intercept form is always the y-intercept, not the x-intercept. So you should never have your first dot on the x-axis when you're dealing with slope-intercept form anyway. So my first dot is going to go right there. And then I'm a little confused because that's supposed to give me a rise and a run, and I'm pretty sure I see a rise there, but I don't see a run. What am I going to do? Because I don't have 2 numbers. Chase, what am I going to do?
Only make the rise.
What?
No.
No, I'm tripping. No. I'm tripping.
It's the one.
Yeah, no,
You're
it's
tripping.
Equals 1. It's the 3 over 1.
Yeah, okay. Where are you getting a 1 from?
Well, because that's what it's equal to.
As a fraction.
Exactly. Yeah. So to turn, oh, sorry. I love your thoughts. All right. So because there's not 2 numbers, you've got to take it and change it into a fraction so that you have a rise and a run. And to turn any whole number into a fraction, stick a 1 underneath it. Over the years, I've seen a lot of kids make this mistake where they put the same number underneath. 3 over 3 simplifies to a 1. So that's going to get you an entirely different slope. So you always stick a 1 underneath it. Coach Morton, the football coach at Ballard that I co-taught with, had this expression that he was like, hey, you need a number? I got 1 for you. Like typically when you need to get a second number for some kind of purpose, it's typically, not always, but 99% of the time it's a 1 that you need somewhere. So he used to always say that. You need a number? I got 1. Okay. So this is a positive slope this time, folks. So from our beginning point, do you think we're going to go up or down? If it's a positive slope and we're talking about our rise, but hey, you can't have any wrong answers when it's a educated guess right now. However, it does turn out your educated guess about up 3 is the correct choice. So 1, 2, or the 3. And again, those loop-de-loops are not part of the graph. I don't require you to do it. If you can get the right answer without doing that part, I'm here for it. I'm just doing it for those of us that are visual so you can see like where I got it from. And then because this is a positive slope, since I went up, do you think I'm going to go to the right or to the left? So up is positive, right? What direction is the right? Is the right positive or negative? Positive. So the right is where the positive numbers are. The left is where the negative numbers are. So if I go up and to the left, what direction am I traveling in overall? A negative direction, because a positive and a negative make a negative. So I want to go up and to the right because that's a positive slope. So once I've gone up 3, I'm going to hop over 1. So my next dot, my next coordinate, I really should speak more mathematically, is going to go right there. And how many coordinates do you need to make sure you did it right? 3. Yes. So we're going to go 1, 2, and up 1, 2, 3 again, and over to the right, so that we've got at least 3 coordinates. Again, don't you dare give me a line that looks like that, please. Okay, that does not go all the way across the graph, and it does not contain arrows. So pretty, please, and thank you. Make sure you extend it all the way across the graph. Okay. What questions you got about this one? You've been doing a lot with working with the equation, so most of this is pretty counterintuitive, is pretty intuitive, not counterintuitive. Okay, but there's a couple that are tricky, okay, which is why I'm working 2 more examples. I'm doing number 3 and number 4 because they represent a couple that can be a little bit tricky for you, okay? So number 3. Oh, sorry. Is anybody not okay if I go to number 3? I think we've kind of got that beginning point down, right? B. We're all going to start right there at the -2 for our beginning point. Now, you would probably think, and rightfully so, hey, that rise is a -6. So I should go down 6. What's the problem with this particular, well, I should say the issue with this particular problem?
It's in red.
Yeah, I don't have enough room on the graph. Now, back in the dark ages, when I was your age, and they made us do our own graph paper, and we had to draw out every single X and Y axis, and it was a lot, like I spent more time drawing the graph, like the grid, than I did actually graphing anything. Okay, it used to not be a problem because I could make myself have enough room. But when I give you a worksheet like this, unless you guys want to start doing your own X and Y axis by hand, sometimes you're going to run into this issue where you want to go down, but you don't have enough room. So you have no choice. You're going to have to go up 6 because you still need a rise of 6. But I'm going to show you how you can still get it to be a negative slope, okay? So 1, 2, 3, 4, 5, and 6. So we still need to go up 6. But keep in mind that a positive is up, right? But a net left is a negative. So instead of going up and to the right like you did to get your positive slope, go up and to the left instead. Because a negative 2, 3, 4, 5 is represented by a change to the left. So your second coordinate is going to go right here. This is also one of those cases where you get to say, I don't have to do 3 coordinates because obviously you don't have room for 3 coordinates on the graph, right? Sometimes that happens. You don't have enough room to go down into, you don't have enough room for a third dot, so you're just going to have to do these 2. So on pre-made worksheets like this, sometimes, or, standardized testing where you've got to like write on it, sometimes you're just not going to have enough room, and that's okay. all right? But you've got to think about this in terms of like direction, and remember your rules for negatives and positives, because direction also follows those same rules. So I'd say that the most common mistake that people make when they're first starting off graphing, we do a great job, honestly, with finding the y-intercept. Typically, that's not a hard thing, but I get a lot of people that do their slopes backwards. Like I would get a positive slope, good morning, instead of a negative slope. So here's a little visual trick that I use in order to, like, I stop and I take a look and I say before I move, actually before I even connect my coordinates, because then I've got a line, you know, that like I have to go back and erase. So before I even connect my dots, I take a minute and I draw a little, because which side of the graph do we start off reading? Do we start reading it on the left or the right? The left. So the left-hand side is always going to be the beginning of your graph. So I draw, I know this is juvenile, but it works, especially if you're a visual learner like me. I draw like a little person on the left-hand side of the graph, and I say to myself, is that person getting ready to go slide down a slide, or is that person getting ready to scale a mountain and go up? They're getting ready to slide down, right? If they move to the right, they're getting ready to go wee, right? So down is a decrease. Did I want to do a negative slope? Yes, I did. So before I even connect my dots with a line, I stop for a minute and I say, hey, do I have it going in the right direction? Like, is that actually decreasing? Because that is by far the mistake that I see the most, is people get their slope backwards. We don't really struggle with the y-intercept part. It's the slope. So number 4 is one of those weird situations, just like number 3. Y equals mx plus b. Okay, so where's my b? Where's my beginning point? Right there on the y-axis. Once again, just like I did in number 3, the direction I really want to go in, okay, my rise is an 8 and is at a positive 8. So I want to go up 8. But I don't have room to go up 8, so I have no choice but to go down 8. You still got to have a vertical distance between your two coordinates. So I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8. Again, you do not need to do those loop-de-loops if it doesn't help you. I'm just doing it to show you like where my numbers came from. And then, so I just went down, which down is negative, right? What do I need to combine a negative with? What makes a positive? 2 negatives, yes. So instead of going to the right, I'm going to go to the left, because if I go down and then I go to the left 5, those 2 negatives are going to give me the positive slope that I want. So 1, 2, 3, and 4. Did I mess that up? I think I might. Wait. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Yeah. 5. And it should be right here. I kind of made it, my little loops were a little too high. So it should be like right there. Okay, so if you do negative and then another negative, 2 negatives do make a positive slope. So I would do my little trick and make sure. So this is going to be the left-hand side of my graph. Is my little imaginary dude getting ready to scale a mountain or slide down a slide? Okay, which is positive. He's getting ready to go up. Is that what I want him to do? Is that a positive slope? Yes. So I did my little trick to make sure I did it right. So now I'm going to connect my coordinates with a line that goes all the way across the graph. And I'm going to, I don't know why I can't get the right color. That's really bugging me. Oh, well, I'm going to stick with that off color for right now. And it has arrows, okay? So on the back page, there are 4 more